Last class I have given you introduction about the capacitor, and I said the capacitor value, the capacitance C, it depends upon the geometrical configuration of the system of two conductors. That means I said it depends upon the shape and size of the conductor and the separation between the conductors are using. So in today's class we will see how we can calculate the value of C if we know the geometrical configuration of the system. We will derive the equation of C. I'll write here parallel plate capacitor. Let me draw a parallel plate capacitor. Consider two parallel plates. Let one plate is positively charged the other one is negatively charged. Let A is the area of the plate and D is the separation between the plates. That the charge on this positive plate is plus Q and the negative plate is minus Q. Now the electric field inside the space between the two conductor is from positive to negative charge. Positive to negative charge. So what would we consider? We considered a parallel plate capacitor or two parallel conductors which are separated by a small distance d, and we took A is the area of the plate, area of each plate, and D is the separation between the plates. And Q and minus Q are the charge on the plates respectively. Now we will do an assumption here. Let D is much smaller than the linear dimension of the plates. So that is, the meaning is D square is very less than A. If this is the case, then we can consider these two parallel plate as two infinite plane sheets with uniform surface density. So while finding out the electric field, we can use the equation which we have derived for the electric field by an infinite plane sheet of uniform surface charge density. If we do this assumption, we can use the result of electric field. So when we find the electric field, so the field, we can use the equation which we have derived for electric field by an infinite plane sheet, field by an infinite plane sheet of uniform surface charge density. Now here, if sigma is the surface charge density of the plates, if the sigma is surface charge density, then for plate 1 the surface charge density is for plate 1 surface charge density sigma as Q by A. So for plate 2 surface charge density is, it is minus Q by A, so I can write it as minus sigma. Now we will find out what is the electric field due to these plates in different regions. For that region, for that case, we'll consider the region outside the plate as region 1. Similarly here, outside it is region 2, and there is a region inside here, means in the region between two plates. We will calculate what are the electric fields. Electric fields in different regions. First is region 1. That is, this is outer region. In region 1, there are two equal and opposite fields. The field due to plus is going away from it. It is sigma by 2 epsilon naught. And there is another field which is towards the negative charge. So due to negative charge, it is in opposite direction, sigma by 2 epsilon naught. So two equal and opposite fields will give out the net field as 0. The net field E is sigma by 2 epsilon naught minus sigma by 2 epsilon naught equal to 0. Now consider region 2. Again, this is also an outer region. Similar to region 1, here also we have two equal and opposite fields. One due to positive charge, another one due to negative charge plate. So it is sigma by 2 epsilon naught. Again here also sigma by 2 epsilon naught. Two equal and opposite fields will give us net field equal to 0. So in the outer region, the electric field is 0. Now what about the inner region? Inner region, that is the region between the plates. Both the fields are in the same direction, and hence in the inner region the two fields add up. We can write in the inner region the electric fields due to two charged plates add up. In the inner region, the electric field due to two charged plates add up. So E is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is equal to sigma by epsilon naught. We have now A is equal to sigma by epsilon naught. We know the charge density is Q by A. So now I can write E is equal to Q divided by epsilon naught into A. Q is E is the potential difference. Potential difference. The potential difference is given by V is equal to E into D. The potential difference V is equal to E into D. Now substitute the value of E here. So E we have as Q divided by epsilon naught into A into D. Also the capacitance C of the parallel plate capacitor C is equal to Q by V. Q divided by V is Q divided by epsilon naught A into D. Q will get cancelled. Q will get cancelled. So Q by V, and here so E into D, no, so here not, so it is E into D, so here D is not on the numerator, sorry. Here Q by epsilon naught A into D is coming into D. So C will become equal to 1 by epsilon naught A. I'll write it this very clearly instead of this. So here Q divided by V, which is equal to Q divided by, what is V we got? We got V as Q divided by epsilon naught A into D. Q will get cancelled. So C will become equal to epsilon naught A by D. This is the capacitance of the parallel plate capacitor. So in this, we took the dielectric or the space between the two regions as a vacuum, or you can take it as air also, air or vacuum. So in that case C becomes equal to epsilon naught A by D. Remember this equation, C is epsilon naught A by D. Depends upon the area of the plates and the distance between the plates.